This is question 11 of the worksheet on complex numbers. Let me just turn off WhatsApp web. It's going crazy today. Okay, so the question is, find two square roots of this complex number. Give your answer in the form of x plus iota y. So we've learned how to find square roots while we were covering this chapter from the book and from example questions. So the method is that you say that let square root of -3 plus 4 iota equals to, it is going to be some complex value where a and b are real. So this a cannot be like 2 iota, it has to be 2. So where a and b are real. All right. Now I'll square both the sides. So -3 plus 4 iota equals a plus iota b whole square. So it's going to be -3 plus 4 iota equals a square plus 2ab plus b square, which is going to be a square plus 2ab iota. Iota square is -1, so it's going to be minus b square equals -3 plus 4 iota. So now I'm going to equate the real terms on both sides and the complex terms on both sides. So the real term here is -3 and the real term here is a square minus b. So -3 equals a square minus b, and the imaginary term or the complex term on one side is 4 and on the other side it's 2ab. So 4 equals 2ab. Now we have to use algebra here. This is minus b square. So I'm going to say that a is 2 by b, and I'm going to substitute this in the other equation. So -3 equals 2 by b whole square minus b square. So I'm getting -3 equals 4 upon b square minus b square. So -3 equals 4 minus b power 4 upon b square. So -3b square equals 4 minus b power 4. So b power 4 minus 3b square minus 4 is equals to 0. Okay, this is a hidden quadratic equation. Let b square equals u. So we're getting u square minus 3u minus 4 is equals to 0. I'm going to solve this in my calculator, but show all the working to the examiner. 1 minus 3 minus 4. That gives u equals 4 and u equals -1. But in order to secure marks, I have to do one back step, which is this. Okay, now replacing u with b square, we get b square equals 4 and we get b square equals -1. You can't get a real solution from here. If you find square root of -1, you get math error. And we initially said that a and b are real, so no solution possible here. And we have two values of b. B is either 2 or b is -2. From here, we will find two values of a. We know that a is 2 upon b. So when b is 2, then a is 1. And when b is -2, then a is -1. Okay, so the two square roots are What did we say our square root was? A square root is supposed to be a plus iota b. So one of our answers is -1, or sorry, 1 plus 2 iota, and the other one is -1 minus 2 iota. And quick reminder, if you're given one of the roots in the question, one of the square roots, not the roots. You're given one of the square roots in the question and you're asked then what's going to be the other square root, you must multiply it with -1. Because even with simple non-complex expressions, we know that if we're finding square root of 25, then we write plus minus here. So it's plus -5. So one of the square root is positive and the other square root is negative. Anyway, so this is what we get. 1 plus 2 iota and -1 minus 2 iota. All right. So that's just the first part of the question. Okay, now let's take a look at part B. I need to clear the screen. I hope everybody has copied this. Okay, the complex number u is given by this. Express u in the form of x plus iota y. That means we have to rationalize the denominator. 7 plus 4 iota. Oops, that's part 1. Okay, so u is 7 plus 4 iota, 3 minus 2 iota, times, when we're rationalizing it, that means we're getting rid of iota term in the denominator, then we multiply and divide with the conjugate pairs. So the conjugate pair of the denominator, 3 minus 2 iota, would be 3 plus 2 iota. 3 plus 2 iota. So it's going to be a square minus b square. And then 7 plus 4 iota, 3 plus 2 iota. And let's multiply the numerator. We get 21 plus 14 iota plus 12 iota and plus 8 times iota square. Iota square is -1. It's going to be -8. Because remember that iota square is -1. Okay, divided by the denominator is 9 minus, that's going to be 4 times -1. So it's actually +4. So the denominator is 13. And the numerator is plus 13 and plus 26 iota. And you have to give your answer in the form of x plus iota y. So you must split the denominator, which gives us 1 plus 2 iota. That is the u in x plus iota y. That's u in x plus iota y form. Any questions here? So this is u. 1 plus 2 iota. Okay. Next part is sketch an argon diagram showing the points representing the complex number u. So now we need to sketch u on an argon diagram, which is 1 plus 2 iota. So you basically have to plot the point 1, 2 on a complex plane. So you write imaginary here and real here. So real part is 1, imaginary part is 2. So here is u. Show On the same diagram, the locals of points of the complex number u such that z minus u is equals to 2. So that's a circle whose center is u because it becomes z equals to u when we equate it to 0. So u is 1, 2. So the center is 1, 2 and the radius is 2. We already have the center plotted. Now we need to make a circle around that such that the radius is 2. So if the radius is 2, that means from the center, we're going 2 units left, right, up and down, and so on. So this 2 needs to go till 4 here. So this will have a point here. And then this 2 needs to go till 0. We'll have a point here. Then it goes 2 to the right here and 2 to the left here. So we get a circle like this. You must use a similar scale on the x and y axis so that you get a proper circle. If you choose different scales on both the axes, then you might get an ellipse, which will not even look like a circle. ऐसा कुछ लगेगा. मेरा भी slightly ellipse लग रहा है because I did not use a scale to mark the points on the x-axis and x-axis. You must do that because that makes a very nice looking circle. Okay, so that's the locus of points representing modulus z minus u equals to 2. It says find the greatest value of argument of z for the points of this locus. Argument of z क्या होता है? किसी को याद है? हम रोज ऑलमोस्ट पढ़ते हैं मॉडुलस एंड आर्ग्यूमेंट. आर्ग्यूमेंट क्या होता है? चलो मॉडुलस क्या होता है? If let's say z is 1 plus 2 iota, what is meant by modulus of z and argument of z? यहाँ लिख लिया मॉडुलस ऑफ z क्या होता है और आर्ग्यूमेंट ऑफ z क्या होता है. Quick recap. Here's the point 1, 2. Here's the point. Modulus is this distance. This is called the modulus, usually represented by r. So for that you apply Pythagoras on this length and this length. So that's why r is square root 1 square plus 2 square. So in this case, the modulus is square root of 5. It's the it's the distance of that point from the center, from the origin. Okay, now what's the argument? Argument is this angle here. So you use tan theta equals y upon x to find the argument. So the argument is the angle that the complex number makes with the x-axis. So now in this question, it says find the argument of z, not of u. And what is z? Z are all these infinite points on the circle. It's saying find the greatest value of argument of z. So let me just choose a z. Let's say this is the z. So is this the biggest angle we can get on the circle, or do you think there's another point that will give us even a bigger angle? What about this point? Here the angle gets bigger. It has a bigger argument. What about this angle? Here the angle at this point, here the angle gets even bigger. So the greatest angle or the greatest value of argument of z you'll get would be somewhere over here. Either koi point over. That will give you the greatest value of argument of z. अच्छा मैं ना z को थोड़ा ऊपर कर रही हूँ क्योंकि it should look like the center of the circle. Let's say either. So that's 1 and 2. Okay. So now we have to find this angle. This is the biggest angle we can take on the locus. So this point, whatever this is, it's not exactly a 2. ये कोई point है. इस पे biggest locus आ रहा है. So let's join it with the center. मजे की figure नहीं बन रही. The center and let me just use a proper circle. Hold on. Let's say this is the circle. Okay, this is the circle whose radius is 2. And the center would be significantly higher. This is the center. Let me just get rid of all the other markings inside. Okay, now this would be 2. Okay, so now I'm going to draw a tangent here. यहाँ पे करें. Let's say this gives us the biggest locus. I mean the biggest argument, sorry. So ये angle हमने find करना. Now how do we find this angle? We know a property from O levels, that is that radius and tangent, they are perpendicular. So I'm going to draw a radius here. This, and I know that this gives me a right angle here. If तो ये चीज आ. Okay. Secondly, I know the length of the radius because it's 2 already known, so that length is 2. Okay. Now, this length here would be what? कर फिर थोड़ा गलत बना. I'm sorry, I'm trying to figure out a figure में क्या गलती है. Something is off about the figure. Sorry, मैंने टेंजेंट ही गलत जगह से बनाया है. जो आर्ग्यूमेंट होता है that's from the center. यहाँ से होता है. मैंने और गलत बना दिया था टेंजेंट. So you must start it from the origin. That was the mistake. So let me just fix that. Okay. So now we're trying to find this angle. To find this angle, I'm going to make use of trigonometry knowledge that I already know from O levels. So I know that the radius and tangent, they make a right angle with each other. And so this length is going to be 2. All right. Now I'm going to join this with the origin so that I get a right angle triangle. Okay, here's the right angle triangle. And then if I join this with this, that's also the radius. So that's 2. As well. And what else? I know this length from here to here, that's 1, right? Now, if that's 1 and that's 2, so this is a right angle as well because x-axis and vertical line up makes a right angle. So now using these two, I can find this using Pythagoras theorem. So that length, the pink length is going to be, let's say this is x and this is O. So xo would be square root 2 square plus 1 square, which is square root of 5. So this length here is square root of 5. 2 पुराना लिखा हुआ है, square root of 5. Okay. Now can I find the angles somehow? Yes, I can. I can use the upper triangle, get this angle, and then I can use the lower triangle and get this angle, and I'll add them, and I'll get the maximum value of argument of C. So for the upper triangle, I'm going to use, some people have, yes, sine theta. Let's call it theta 1 and call this theta 2. So sine theta 1 is perpendicular upon hypotenuse. And for theta 2, I'm again going to use sine theta 2. Actually, they're both coming out to be the same. So sine theta 2 is the same as well. perpendicular over hypotenuse. So find this angle and then multiply it with 2. So it's going to be sine inverse 2 by under root 5, which is 1.1071. And when you find theta 2, you'll get the same thing, 1.1071. So the answer would be this plus this, which is answer times 2, which is 2.21429. So answer must be rounded to 3 significant figures, so it's going to be 2.21. So I've given the answer in radians. You may give it in degrees as well. Since radians was not specified or degree was not specified, so it's up to you. Okay, that was question 11. It was a lengthy one. कोई question है तो please पूछो. Okay. So I would recommend redo this question at home, especially the last part. जिसमें argument diagram बनानी है और maximum value of argument of C find करना है, because you will see lots of questions like this in the past papers. So make sure you've completely understood this concept while we're at this chapter. Okay. So question number 12, which is the complex number u is given by this, express u in x plus iota form. Let's quickly do that. U is 3 plus iota over 2 minus iota. We will multiply and divide with the conjugate pair, which is 2 plus iota and 2 plus iota. When we do this, we get rid of the iota term from the denominator and we get x plus iota y form. Okay, so the denominator is going to be a square minus b square, and numerator is going to be 6 plus 3 iota plus 2 iota plus iota square, which is minus 1. So I have 5 plus 5 iota in the numerator, and in the denominator I have iota square minus 1. And minus 1 minus 1 becomes plus. So there's a 5 in the denominator as well. And when you break the denominator, you get 1 plus iota. Okay, that's part 1. Part 2 says find the modulus and argument of C of U. I hope you now remember what is a modulus, what is an argument. Not that you have to make this figure, but I'm just going to show it to you. Modulus is this length. So that's why we apply Pythagoras theorem when we're finding the modulus. So modulus of U is going to be square root 1 square plus 1 square, which is under root 2. And argument is this angle here, which is tan inverse 1 upon 1. I've applied tan theta equals 1 upon 1. So send tan to the other side. Tan inverse 1 is 45. And if I'm in radians, it's going to be pi by 4. Okay. So modulus of Z is under root 2. Modulus of U and argument of U is pi by 4. Sketch an argument diagram showing the points representing the complex number U, which is just 1 plus iota. Imaginary axis, real axis, 1 plus 1 iota. So here is the point U. Also, you have to plot the locus of points representing this. So that's a circle whose center is U. and radius is 1. It's going to be a circle with radius 1, something like this. This is going to be 2. That's going to be 2 here as well. Okay. Using your diagram, calculate the least value of that symbol is for modulus of C. Now we have so many possible values of C on this Argand diagram. It can be anywhere on this circle, but we have to choose that Z which gives us the smallest value of modulus of C. And remember what's modulus? It's the distance of the point from the origin. So if I choose this point on the circle, this can't be the smallest most distance, because if I take this one, then the distance is smaller. But if I take this one, then the distance is the smallest. So that means you have to choose a point here and find this length. That's going to be the smallest possible value of modulus of C. Now to find this, what I'll do is connect this to this. And I know that this length here is 1. Yahan se yahan tak is 1 because that's the radius. So if I can find that entire length and subtract 1 from it, then I'll have the modulus, minimum value of the modulus. Then I know that this length is 1. And I know that this length is also 1. Yahan se yahan. So now I'm going to use Pythagoras theorem and get that entire length from the center, let's call it X, to the origin O. So the length XO is going to be square root of 1 square plus 1 square. That is square root of 2. So that entire length is square root of 2, but from it we'll subtract 1. And we get the modulus of, the smallest possible modulus of C, square root of 2 minus 1. We are not asked to give the answer in exact form, and you're not asked to give the answer correct to certain significant figure. So you may leave it like this, or you may find round it off to 3 dB, 3 significant figures. All right. So let's end the lesson here. And I'm going to leave you guys with some homework, probably question 13 and 14. ठीक है, वो प्लीज करके लाना ताकि बस अब इस चैप्टर को कंक्लूड करें हम. ठीक है, टेक केयर, अल्लाह हाफिज. I'm not starting the question क्योंकि वो खत्म नहीं होगा, और secondly खुद try करो. I'll see you guys tomorrow. Take care. Allah Hafiz.
Allah Hafiz.